How does the fully connected layer work in science? Imagine a computer trying to recognize a picture of a cat. It looks at different features like whiskers, ears, and eyes. But how does it decide if the picture is really a cat? That's where the fully connected layer comes into play. It acts like the final decision maker in a convolutional neural network. After the network's earlier layers extract features from the image, these features are gathered into a single long list called a feature vector. Think of it as a summary of everything the network has learned about the image so far. This vector is then fed into the fully connected layer. Every neuron in this layer is connected to all the features in the vector. It's like a big web where each neuron listens to all the features at once. Each neuron in the fully connected layer takes all these features, multiplies each one by a specific weight, adds them all together, and then adds a bias. This sum is then passed through an activation function, like ReLU or softmax, which helps the network decide how strong or confident the prediction is. During training, the network adjusts these weights and biases to improve its accuracy. If the network is trying to find a cat, the fully connected layer combines all the clues from earlier layers, like whiskers, ears, and eyes, and figures out if they match what a cat looks like. It then outputs a number or probability that indicates if the image contains a cat or not. In deep learning and specialized artificial intelligence, these fully connected layers are like the brain's decision centers. They turn all the learned features into a final answer. For example, models like ChatGPT use dense layers to interpret language, while image tools like DALL-E or Midjourney use neural networks to generate visual content. It's also important to remember that the decisions made by these layers depend on the data they were trained on. If the data has biases or gaps, the output might be unfair or incorrect. That's why careful training and good data are essential. To sum up, the fully connected layer in convolutional neural networks gathers all the features, combines them, and makes the final call. It's the part that turns all the complex visual or textual clues into a clear, understandable result.